The next topic that I chose was subatomic particles. The way I set out this question was to fill in a chart. So here is the question. That is the chart. The reason I chose this topic was because I struggled with this in the beginning and knowing the relationships between the subatomic particles and an element. So what I will do is basically, I'm going to break down how to find each one of these things and just go across the first couple of rows. Here, let's bring this so you guys can see it. There we go. So the first element that was given is magnesium, Mg. To find the atomic number of magnesium, because the actual symbol of the element is given, you could actually just look at the periodic table. But the other Q to being able to find which element this is knowing the protons. The relationship of the protons is also the atomic number, and the atomic number is how the elements are arranged on a periodic table. So if you know the protons, you'll know the atomic number and vice versa. The number of electrons is also equal to the number of protons, as long as the element is not an ion. An ion is the gaining or losing of electrons. To find the neutrons, you have to know the mass number. The mass number is located usually at the bottom of an element on the periodic table. The mass number is the total weight of all of the subatomic particles. Protons and neutrons. Electrons don't have hardly any weight. To find the neutrons, you would subtract the number of protons from the mass number. So, for the very first row, sorry, I'm moving a lot. Magnesium has 12 protons, so its atomic number is 12. The number of electrons it has is also 12 because this is not an ion. The mass number, which is given on the periodic table, is 24, rounded. And to find the number of neutrons, you round the mass number to the biggest whole number and subtract the protons. 12 minus 24 minus 12 is 12. So that is how I found all of the different subatomic particles for magnesium. Now the next one, the element was not given. The protons and the atomic number was not given. The only thing that was given is the mass number. So for that, you would have to look at the periodic table and see what element had a mass of 28. From going to the periodic table, I found that silicon is the one with a mass number of 28. From there, you can see that the atomic number is 14. Therefore, the number of protons is 14, which means the number of electrons, so long as it's not an ion, which this is not, is also 14. By subtracting 14 from 28, we find that the number of neutrons is also 14. The next row, we are given the atomic number. For this, we know if we have the atomic number, we can go straight to the periodic table, look for 10, and find what the element is. This also tells us how many protons there are, electrons if it's not an ion, and from finding it on the periodic table, we can find what the mass number is. I found that the atomic number, 10, is neon. And this is how you would go about to find the rest of this chart. Knowing the different relationships between the subatomic particles is very important.